Easily see that they are so small that if they creep into a flower they pass the anthers without rubbing against them, and so take the honey without doing any good to the plant. Ants are in many cases great enemies to them, for they like honey as much as bees and butterflies do, yet you will easily see that they are so small that if they creep into a flower they will pass the anthers without rubbing against them, and so take the honey without doing any good to the plant. Therefore we find numberless contrivances for keeping the ants and other creeping insects away. Look for example at the hairy stalk of the primrose flower. Those little hairs are like a forest to a tiny ant, and they protect the flower from his visits. The Spanish catchfly, or Silenia otitis, on the other hand, has a smooth but very gummy stem, and on this the insects stick if they try to climb. Slugs and snails too will often attack and bite flowers unless they are kept away by thorns and bristles such as we find on the teasel and the burdock. And so we are gradually learning that everything which a plant does has its meaning if we can only find it out, and even very insignificant hair has its own proper use. And when we are once aware of this, a flower garden may become quite a new world to us if we open our eyes to all that is going on in it. But as we cannot wander among many plants today, let us take a few which the bees visit, and see how they contrive not to give up their honey without getting help in return. We will start with the bluewood geranium, because from it we first began to learn the use of insects to flowers. More than 100 years ago, a young German botanist, Christian Conrad Sprengel, noticed some soft hairs growing in the centre of this flower, just around the stamens, and he was so sure that every part of a plant is useful that he set himself to find out what these hairs meant. He soon discovered that they protected some small honey bags at the base of the stamens, and kept the rain from washing the honey away, just as our eyebrows prevent the perspiration on our faces from running into our eyes. This led him to notice that plants take great care to keep their honey for insects, and by degrees he proved that they did this in order to tempt the insects to visit them and carry off their pollen. The first thing to notice in this little geranium flower is that the purple lines which ornament it all point directly to the place where the honey lies at the bottom of the stamens, and actually serve to lead the bee to the honey. And this is true of the veins and markings of nearly all flowers, except of those which open by night, and in these they would be useless, for the insects would not see them. When the geranium first opens, all its 10 stamens are lying flat on the corolla or coloured crown, as in the left-hand flower in figure 58, and then the bee cannot get at the honey. But in a short time the 5 stamens begin to raise themselves, and cling around the stigma or knob at the top of the seed vessel, as in the middle flower. Now you would think that they would leave their dust there, but no, the stigma is closed up so tight that the dust cannot get onto the sticky part. Now, however, the bee can get at the honey glands on the outside of the raised stamens, and as he sucks it, his back touches the anthers or dust bags, and he carries off the pollen. Then, as soon as all their dust is gone, these 5 stamens fall down, and the other 5 spring up. Still, however, the stigma remains closed, and the pollen of these stamens too may be carried away to another flower. At last these 5 also fall down, and then, and not till then, the stigma opens and lays out its 5 sticky points, as you may see in the right-hand flower in figure 58. But its own pollen is all gone. How then will it get any? It will get some from some bee that has just taken it from another younger flower. And thus you see that the blossom is prevented from using its own pollen, and made to use that of another blossom so that its seeds may grow healthy and strong. The garden nasturtium, into whose blossom we saw the humble-bee poking his head, takes still more care of its pollen dust. It hides its honey down at the end of its long spur, and only sends out 1 stamen at a time instead of 5 like the geranium. And then, when all the stamens have had their turn, the sticky knob comes out at last for the pollen from another flower. All this you may see for yourselves if you find geraniums in the hedges and nasturtiums in your garden. Footnote: the scarlet and other bright geraniums of our flower gardens are not true geraniums but pelargoniums. You may, however, watch all these peculiarities in them if you cannot procure the true wild geranium. Even if you have not these, you may learn the history of another flower quite as curious, and which you can find in any field or lane, even near London. The common dead nettle, figure 59, takes a great deal of trouble in order that the bee may carry off its pollen. When you have found one of these plants, take a flower from the ring all around the stalk and gently tear it open so you can see down its throat. There, just at the very bottom, you will find a thick fringe of hairs, and you will guess at once that these are to protect the drop of honey below. Little insects, which would creep into the flower and rob it of its honey without touching the anthers or the stamens, cannot get past these hairs, and so the drop is kept until the bee comes to fetch it. Now look for the stamens. There are 4 of them, 2 long and 2 short, and they are quite hidden under the hood which forms the top of the flower. How will the bee touch them? If you were to watch one, you would find that when the bee alights on the broad lip and thrusts her head down the tube, she first of all knocks her back against the little forked tip. This is the sticky stigma, and she leaves there any dust she has brought from another flower. Then, as she must push far in to reach the honey before she comes out again, she's carried away the yellow powder on her back, ready to give it to the next flower. Do you remember how we noticed at the beginning of the lecture that a bee always likes to visit the same kind of plant in one journey? You'll see now that this is very useful to the flowers. If the bee went from a dead nettle to a geranium, the dust would be lost, for it would be of no use to any other plant but a dead nettle. But since the bee likes to get the same kind of honey each journey, she goes to the same kind of flowers, and places the pollen dust just where it is wanted. There is another flower called the salvia which belongs to the same family as our dead nettle, and I think you will agree with me that its way of dusting the bee's back is most clever. The salvia is shaped like the dead nettle, with a hood and a broad lip, but instead of 4 stamens it has only 2, the other 2 being shriveled up. The 2 that are left have a very strange shape, for the stalk or filament of the stamen is very short, while the anther, which is in most flowers 2 little bags stuck together, here has grown out onto a long thread with a little dust bag at one end only. In figure 60 you can only see one of these stems because the flower is cut in half, but in the whole flower one stands on each side just within the lip. Now when the bee puts her head into the tube to reach the honey, she passes right between these 2 swinging anthers and, knocking against the end, pushes it before her, and so brings the dust bag plump down on her back, scattering the dust there. You can easily try this by thrusting a pencil into any salvia flower and you will see the anther fall. You will notice that all this time the bee does not touch the sticky stigma which hangs high above her, but after the anthers are empty and shriveled, the stalk of the stigma grows longer, and it falls lower down. By and by another bee, having pollen in her back, comes to look for honey, and as she goes into flower number 3, she rubs against the stigma and leaves upon it the dust from another flower. Tell me, has not the salvia, while remaining so much the same shape of the dead nettle, devised a wonderful contrivance to make use of the visits of the bee? The common sweet violet, Viola odorata, or the dog violet, Viola canina, which you can gather in any meadow, give up their pollen dust in quite a different way from the salvia, and yet it is equally ingenious. Everyone has noticed what an irregular shape this flower has, and that one of its purple petals has a curious spur sticking out behind. In the tip of this spur, and in the spur of the stamen lying in it, the violet hides its honey, and to reach it the bee must press past the curious ring of orange-tipped bodies in the middle of the flower. These bodies are the anther, figure 61, which fit tightly around the stigma, so that when the pollen dust, which is very dry, comes out of the bags, it remains shut by the tips as if in a box. 2 of these stamens have spurs which lie in the coloured spur of the flower, and have honey at the end of them. Now, when the bee shakes the end of the stigma, it parts the ring of anthers and the fine dust falls through upon the insect. Let us see for a moment how wonderfully this flower is arranged to bring about the carrying of the pollen, as Sprengel pointed out years ago. In the first place, it hangs on a thin stalk and bends its head down so that the rain cannot come near the honey in the spur, and also so that the pollen dust falls forward into the front of the little box made by the closed anthers. Then the pollen is quite dry, instead of being sticky as in most plants. This is in order that it may fall easily through the cracks. Then the style or stalk of the stigma is very thin and its tip very broad, so that it quivers easily when the bee touches it, and so shakes the anthers apart, while the anthers themselves fold over to make the box, and yet not so tightly but that the dust can fall through when they are shaken. Lastly, if you look at the veins of the flower, you will find that they all point towards the spur where the honey is to be found, so that when the sweet smell of the flower has brought the bee, she cannot fail to go in the right place. 2 more flowers still I want us to examine together, and then I hope you will care to look at every flower you meet to try and see what insects visit